Hello everyone, this is Kunika Chandra from Shivaji College, Delhi University. So in this video, we will be continuing our topic on amines. So let's have a quick look at the overview of this lecture. So this topic of amines was divided into two parts. Part 1 was covered in the previous video. So in this video, we will be talking about part 2, where we'll do some distinguishing tests for 1 degree, 2 degree, and 3 degree amines, namely Carbolamine Test, Hensberg Test, and reaction with nitrous acid. Then we'll move on to Diazonium Salts, where we'll learn about their stability and how they're prepared and some reactions that they show. In the previous lecture, we discussed about amines, their preparation, and some reactions that they show. So in this lecture, we would be discussing some distinguishing tests we do to identify between 1 degree, 2 degree, and 3 degree amines. We would be doing it by these three tests. So let's get into them. So the first one is the Carbolamine test. According to the basic reaction, if we react an aliphatic or aromatic primary amine with chloroform and alcoholic KOH, we get a foul-smelling compound called carbolamine. So here I've taken two examples. The first is an aliphatic primary amine, and here aniline is an aromatic primary amine. In both cases, we are getting a substance called isocyanide. So that's why this test is also called as the isocyanide test. And it's a very simple test. You just have to take your amine and react it with chloroform and alcoholic KOH. And if the reaction yielded a foul smell at the end, we would know that it is a 1 degree amine. Next distinguishing test is the Hensberg test. So here we are reacting our 1 degree, 2 degree, and 3 degree amines with a reagent called Hensberg reagent, and it's generally called benzene sulfonyl chloride, and here's the structure. So let's read about it. Hensberg reagent distinguishes between 1 degree, 2 degree, and 3 degree amines by making compounds either soluble or insoluble in alkali. So let's see in the further slides how it's done. So here I have the 1 degree amine and the Hensberg reagent. When I react them, over here I can see that one of the H and Cl would get out in the form of HCl, and we will get this compound called N-alkyl benzene sulfonamide. Now when I put KOH into it, it would make this structure, and this structure is actually soluble in KOH. So if I'm reacting an amine with Hensberg reagent and upon adding KOH also, it becomes soluble, so we'll say that it is a 1 degree amine. Second is the 2 degree amine. Over here again, the H and Cl would get out, and we are getting a compound called N-dialkyl benzene sulfonamide. Now, when I would put KOH into it, it would not be soluble and it would be insoluble. So this is how we would distinguish it between 2 degree amine using a Hensberg reagent. Third is the 3 degree amine. So we can see here that there is no hydrogen at all to react with the Cl. So there would be no reaction at all, and it would be pretty obvious that the compound form would also be insoluble in KOH. So this was the Hensberg reagent test. Next is a reaction with HNO2, which is the nitrous acid. So this nitrous acid is prepared in situ, means it is prepared in the reaction vessel itself, because it's so unstable that we cannot prepare it outside and then use it in our reaction. So we make it in our reaction itself. So how does this nitrous acid help us in distinguishing 1 degree, 2 degree, and 3 degree amine? So here I have a brief. In 1 degree amines, it would make an alcohol. For 2 degree, it would make a yellow oily compound, and for 3 degrees, it would make a water-soluble salt. So let's see in the further slides how it's done. The first one is the 1 degree amine. Now, in the further slides, we would read about diazonium salts, and we know that when we make diazonium salt out of aliphatic amine, it's unstable even at low temperatures, so it decomposes immediately to give alcohol. Now this is the feature of aliphatic diazonium salts that we can use to test a 1 degree amine. Second is the 2 degree amine, where I have again used HNO2, and now I am getting N-nitrosamine, which is a yellow insoluble oily compound. So if I'm having an amine and reacting it with nitrous acid and we get a yellow oily compound, we can ascertain that it is a 2-degree amine. Next I have 3-degree amine. Here we have no hydrogen left, so we are getting a salt formation of this kind called trialkyl ammonium nitrite, and this is a salt which is soluble in water. So when I am reacting an amine with HNO2 and I get a water soluble salt, so it means that I'm having a 3-degree amine. So these were some simple tests that we did to distinguish between 1-degree, 2-degree and 3-degree amines. Now we are going to start with a new topic called Diazonium salts. So the general formula is Ar, which is aryl group, N2 plus and X minus, where this N2 plus is called as the diazo group. Now, as we did in the previous slide, aliphatic diazonium salts decompose readily to give alcohol because they are so unstable. That's why in the general formula we are using the aryl and not an alkyl group. Coming on to the stability, aliphatic diazonium salts are unstable and aromatic are stable. We will see in the further slides how they are stable and unstable. Starting from the discussion of the stability of aliphatic amines, so when we react it with nitrous acid in C2, in even low temperatures, it's still unstable because this way the R positive would get out, and as we had seen in the previous slides, even small amount of water would lead to the formation of alcohol because OH minus got attracted to this R plus, and the nitrogen takes the electrons over it and separates out as a nitrogen gas, and Cl minus would also get out. So like there's nothing left in the aliphatic diazonium salt. It disintegrates so easily, that's why they are unstable. Next we'll discuss about the stability of aromatic amines. So here we can see that it has 5 resonance structures, and at ortho and para position we have the positive charge, but it is only possible for a short time when the temperature is really low between 0 to 5 degrees, and that's why due to the dispersal of positive charge the aromatic amines make stable diazonium salts. Moving on to one of the most important topics, that is the synthesis of diazonium salts, means how we prepare them. So the first is the diazotization reaction. It is the most common reaction to prepare a diazonium salt, where we are performing a diazotization reaction on the aromatic primary amines. Diazotization reaction means incorporating a diazo group into a primary aromatic amine. So this is the basic reaction. In the next slide, we'll do its mechanism. So step 1 of the reaction mechanism, here we've taken the HNO2 acid and an H plus, where we are making a nitrosonium ion. Now in step 2, this nitrosonium ion reacts with a aromatic primary amine like aniline and makes this compound over here. And in step 3, the hydrogen is getting out from here and then taken up by the oxygen, which is having some lone pairs. In step 4, the same thing is happening until we get OH2 over here. In step 5, the water finally comes out and we get our diazonium salt. So this was the reaction mechanism of preparing an aromatic diazonium salt. So next we come on to some reactions that diazonium salts show. So they're basically conversion reactions and how we prepare benzene and phenol from them. So the first is conversion of diazonium salts to benzene. Here the diazo group, which is the N2 plus group, is replaced by an H atom. So we have just taken H3PO2 and water and heated them to make benzene. Another method to make benzene is to add alcohol in the diazonium salt, and again we are getting benzene, but in this case we are also getting acetic acid and nitrogen gas along with it. The next is the preparation of phenol by diazonium salts. Here the diazo group would get replaced by a hydroxyl group. So we just have to add warm water in the presence of a little acid and we would get phenol from diazonium salt along with some nitrogen gas and HCl. Third is the preparation of dyes. So over here we are not having the replacement of diazo group but the retention of this group, and it's also called as a coupling reaction. So let's read what's written over here. Retention of diazo group to produce colored dyes by coupling with rings of highly reactive molecules like phenol, aniline, and beta-naphthol. So looking at the basic reaction, if we react an arene diazonium salt with one of these reactive species, we get brightly colored compounds called azo compounds. So in the next slides, we'll see how they're made. So first we are reacting the diazonium salt with phenol. So in this way, the HCl would come out and we would get p-hydroxyethylbenzene, which is an orange colored dye. And the next reaction is with aniline, which is happening in almost the same fashion. The HCl is getting out and we're getting p-aminobenzene, but this time we are getting a yellow colored dye. So these dyes are very important in manufacturing a lot of things, and that's why this reaction of making azo compounds is really important in chemistry. The third is the reaction with beta-naphthol. It is again a very reactive compound, and when it reacts with the diazonium salt, we get a compound of this manner, and it is again an orange colored dye. So that ends the part 2 of our lecture on amines. Let's get a quick recap at what all we covered. So we started with the distinguishing tests of amines, where we distinguish between 1 degree, 2 degree, and 3 degree amines. The first method was Carbolamine Test, where we were producing foul-smelling compounds called carbolamines or isocyanides, and this was the test shown exclusively by the 1 degree amine. The second was Hensberg Test, which was shown by all the 3 types of amines, and they were giving us compounds which were either soluble or insoluble in alkali. The third was reaction with HNO2, and it again helped us to distinguish between 1 degree, 2 degree, and 3 degree amine by producing alcohol, yellow oily insoluble compound, and water soluble salt respectively. The second set of topics we did was about diazonium salts, where firstly we did the general formula and about their stability, how aliphatic diazonium salts were unstable and aromatic ones were stable. The second was their preparation, where we prepared them with the help of a diazotization reaction. And the third were some reactions that diazonium salts showed, which was basically the preparation of benzene, phenol, and azo dyes. So I hope this lecture was clear, and thank you for watching.